Video, we're going to do some guided exam question practice on the question 13 that came up on the 2022 mock paper. All right, so it's worth 30 marks, so you got about 10 minutes, so set your timer and we'll get stuck into it. All right, so there's a bit of a blurb here and a bit of text that we need to read, and I'm guessing that some of it's probably going to be quite important, so we're just going to have a quick read of it here. It says, a teacher carried out a demonstration to help students visualize the effect of changing a number of factors. So we've got a number of different factors that affect, that we want to see how do they affect the rate of a chemical reaction. A quick reminder, what does rate mean? Rate means the speed. So the speed that the reaction happens at. There's a number of factors that we're checking to see how they affect the speed. In the demonstration, hydrogen peroxide, H2O2, this chemical, breaks down to form oxygen gas and water. Now, we did this experiment in class. It says here then the students assisted the teacher by measuring the time taken for a fixed volume of oxygen gas to be produced. And the following results were obtained. Now we've got a table, and it's important that we learn and practice how to read this table. So the first thing here is that there are 4 versions of the experiment. So we did 4 different experiments. That's what this is saying, that there were 4 different experiments. And in each experiment, some of the factors that affect chemical reactions were changed. Now, quick reminder, here's a little bit of revision for you in your practice copies or wherever you work. Let's quickly see, can we retrieve what are the factors that affect the rate of a reaction? Rate of reaction. So what I want you to do is pause the video and reproduce or make this mind map. There are 4 factors that we learned about. So pause the video and do that now. Okay, so the first thing we should have remembered is that the first thing that can affect the rate of a reaction is the temperature that you do the reaction at, the temperature. Okay, so changing the temperature can make the reaction go faster or slower. The second thing that affects the rate of reaction is concentration. So the concentration of the reactants. So how concentrated or how dilute they are. A third thing that affects the rate of a reaction is what we call the surface area of the reactants. Surface area. Okay, so we can make the surface area bigger or smaller, and we can make the surface area bigger by crushing the substance into smaller pieces. The final thing that affects a rate of reaction is the use of a catalyst. A catalyst is a substance that speeds up a chemical reaction. So these are the 4 things or the 4 factors that affect the chemical rate of a chemical reaction. So back to the table and let's have a look at the factors. So this is one factor, the concentration of this reactant, H2O2. Then we have temperature is changed, or we can change a catalyst. So these are the 3 factors that we're manipulating, and we're checking to see the impact on this pink arrow here. How does that impact the time taken for oxygen gas to be produced? Okay, so let's quickly have a look at the experiment. We see in the first experiment, we used a concentration of 10 for the hydrogen peroxide. With a temperature of 20, and the catalyst was used. In the second experiment, we had a concentration of 10, so no change from the first one. These are the same, hopefully you can see that. But the temperature is different. The temperature was increased, so different. And there's a catalyst used, which again is the same. So hopefully you can see that the only thing that changed between experiment 1 and 2 is that the temperature was put up. The other 2 things were kept the same. The concentration and the catalyst were kept the same. In the third experiment, we used 10 again of the concentration, so that was the same. The temperature was back to the original one, same as the first experiment, but this time we changed that there was a catalyst used. So this time, a catalyst, sorry, was not used. This time we had no catalyst. So this is changed this time. And in the last one, we've used a concentration of 20. So this is now not the same anymore. So the first 3 were the same concentration. This last one is now different. Whereas the temperature is back to being the same as the first and the third one. So it's the same as the original temperature, and a catalyst is used, which is the same as the first one. So the only thing that's different in this one is that we've used a different concentration. So in each experiment, we're changing one thing. Okay, so hopefully we can see that. All right, let's go down to the questions now. It says from the table, so you looking up at the table, name 2 factors that the class investigated. So pause the video and write down 2 factors that the class investigated. Pause the video, do that now. Okay, so the 2 factors, there are 3. You could write this one, or this one. So hopefully you have written those. So the first one could be concentration of H2O2. That was one thing that was changed, one factor that was investigated. Another factor that was investigated was the temperature. You could have had that one, and you just needed two. The last one that could have been, you could have said was investigated, was the use of a catalyst. Use of catalyst. So catalyst was either there or it wasn't there. Those were the three factors. You needed two of them. On to the next one. What could the class conclude when the results of experiment 1 are compared with the results of experiment 2? So for this question, we can forget all of experiment 3 and 4, and we're just comparing 1 and 2. And what we're saying is, what could we conclude? What's the difference between them? Okay, so what could we conclude? So the only thing that's different between 1 and 2, we said, was the temperature. Okay, so looking at the temperature, in experiment 2, the temperature is higher than experiment 1. So now that you know that, I want you to tell me, what conclusion can we make? How does that impact the result? So pause the video and write down a conclusion here. Pause the video, do that now. Okay, so a conclusion we could make here is that we have increased the temperature. Increasing the temperature. I want you to write about how does it impact the result. Pause the video and write it down if you haven't already. Increasing the temperature has caused the time for the oxygen gas to be produced to decrease. So increasing temperature has decreased the time taken for the oxygen to be produced, or it has made the reaction go quicker. So increasing the temperature decreases the time taken for oxygen to be produced. An alternative answer again here, I'll remind you, is that increasing the temperature has increased the speed of the reaction because the oxygen is now being made quicker. Right, on to the next bit. What could the class conclude when the results of experiment 1 are compared with the results of experiment 4? So now that we've shown you how to do B, you should now be able to look at 1 and 4 and write a conclusion about them. What I'm going to do is I'm just going to leave it. So I'm going to get you to pause the video and write down a conclusion we can make when we compare experiment 1 and 4. Okay, so you'll only be watching the video if you've written an answer for part C. Okay, what's different about experiment 1 and experiment 4 this time? Well, the only difference between 1, there's a catalyst present in both. So here we see catalyst yes and catalyst yes. The temperature is the same in both, 20 and 20. And the only difference is that the concentration of H2O2 was 10 in the first experiment, but it was 20 in the fourth experiment. How does it impact the results? Well, what are the results here? 16 seconds for the oxygen in the first experiment and only 8 seconds for the oxygen in the second experiment, in the fourth experiment. So we're going to go and write about that now. So what we can conclude is that we increasing the concentration, increasing the concentration of H2O2, because that's what we did, decreases the time taken to collect the oxygen, collect the oxygen gas. Again, you could have also said speeds up how quickly, or makes the oxygen be produced more quickly. You could have said something like that. So increasing the concentration of H2O2 increases the speed that the oxygen is made at, something like that. All right, on to the next question. Is a catalyst needed? So is the catalyst needed for this reaction to happen? Is it needed? Justify your answer. Let's go back to the table. Does the reaction require a catalyst or not? If you think you can answer this, go ahead and pause the video and make sure you justify. Justify, guys, means give a reason for your answer. So is a catalyst needed? Justify your answer. Pause the video and write that down now. All right, so if you weren't able to see this, a little bit of help. Where's the experiment where they didn't use a catalyst? The experiment where they didn't use a catalyst was number 3 here. No catalyst was used. Now, it says that the oxygen gas was still produced, but it took a few months. It took a long time. So really, both answers, yes and no, are correct here, so long as you give the correct reason for it. So one version of this, and I think this is the better version, is the catalyst required? And most of my students answered this. We said, no, it's not required. How do we know it's not required? No, where the oxygen is still produced, but it takes a really long time, or it takes a few months, you could say. So it can still happen without the catalyst. It just takes really, 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 really slow. So this is, in my opinion, is the best answer here. This is the best answer. Now, you could have also said yes, because the reaction takes too long without it. I don't think this answer is as good, but they were accepting this. So I prefer the first answer a lot. I prefer it a lot more. But yes, because the reaction takes too long without it. So technically that is kind of true, too long without it, but it's just not that accurate. I saw they were accepting it on the marking scheme, so we kind of have to tell you about that, but I still think technically that second answer is kind of wrong. Okay, the first answer is the real correct answer there. All right, on the next one. The energy profile diagram for this reaction is shown below. Now, we studied energy profile diagrams in class. I think a lot of people missed that this was an actual question. It says on the diagram, show using an arrow the activation energy. A lot of people seem to do nothing on this graph, and I don't know whether that means you don't know how to do it or that you didn't realize that that was a question. I'm going to take it that you didn't realize that that was a question. So where is the activation energy? Now, I'm going to show you what a lot of people did. A lot of people who did answer it, they did this. And they said activation energy. Activation energy. Now, technically, that's not quite correct. You should be using an arrow like this that shows a certain amount of energy. How high is the amount of energy? So now that I've told you about that, what I want you to do is sketch out this reaction profile and add the activation energy. So technically, this is not quite right. So I'll get you to pause the video and do that now. Okay, so what you should have done again is sketched out this rough sketch, labeled it the same way it is here, and then you're going to show the activation energy. Now, there's two places you can do this. You can either do this, show, okay, this is the height of the hill, if you like. This is the height of the energy, the amount of energy that reaction has to get. And from the reactants up to the top of the hill, this arrow here represents the activation energy. So again, you'd have to label it. That's the first thing that you could do. The second place you could put it is to maybe not do it there and say, okay, I'm going to continue the level of the reactants, and then I'm going to show that the activation energy is from here up to here. It's the exact same thing, it's just you're doing it in a different place. And I would say this is the activation energy. So either one of them is okay, but this here just pointing at the top of the hill, that's not really showing the activation energy. It's showing the maximum energy. It's showing, it's showing this is how high, this is the level of energy you got to get up to, but it's not showing that the activation energy is from the reactants up to the top of that hill. All right, on the next one, it says which of the labels X or Y, so here they are, X or Y, represents the energy of the reactants in the reaction. So pause the video and write down which one do you think it is, X or Y. Okay, well, hopefully this here, you can realize that this shows reaction progress. Reaction progress. As we go from left to right, the reaction is progressing. So Y is coming before X on that axis. So Y is here early on that axis, so this is at a low level of reaction progress. And then towards the end of the reaction, we have X. So where are the reactants in a chemical reaction? So that should give you enough that you need to go ahead and get this right now. Pause the video and make sure you have label is X or Y, the reactant. Pause the video. Okay, you should have said that Y is the reactant. Why? Because it's early on in the reaction. Look where it is. It's here at the start. X is at the end. So we know that during a chemical reaction, we start with the reactants and we turn into products. So at the end of the reaction, this line here, this shows us the energy of the products. And at early, this line here shows us the energy of the reactants. On to the next bit. Which of the labels X or Y represents the energy of the products of the reaction? Okay, so obviously, now that I've told you that Y is the reactants, that X is the products. Is this reaction endothermic or exothermic? Explain your answer. So is energy released or is energy taken in this reaction? Pause the video and write your answer. Then don't forget to explain it for the rest of the marks. You have to explain. Okay. Okay, so you're going to be watching if you've had a good go at this now, and you've had a good go explaining if it's endo or exothermic. The first thing to know is, well, if we were to go from the reactants, which is the level at Y, we can see that down to X, the energy in the system has dropped. It has dropped, okay? So this is an energy drop to get to X. So that means there is less energy here in the products. So where has that energy gone? The energy had to go somewhere. It went to the surroundings, So because the energy of the products is less than the energy of the reactants, energy was released to the surroundings. So if you haven't thought about that, maybe you can have another go at answering this now. Double check your answer. Okay, so hopefully you've said that this reaction is exothermic. Exothermic, that would have got you some of the marks. But is it endo or exo? You should have said exo. And then why is it exothermic? It's exothermic because energy of the products is less than the energy of the reactants. So energy was released. And therefore that makes it exothermic. Right, guys, that's that question, 30-mark question. Some of us did very well on it, but some of us definitely lost marks in certain places, especially here in part E, and a few lost marks in part F, and definitely a couple of us lost marks on B and C. Just being careful not to, we didn't really use our data, our information from the table properly when we're answering B or C. All right, guys, if you found this video useful, drop the video a like because it'll help other students who need help as well to find this video. And other than that, we'll see you in the next video for another question review.